Hello, YouTube. I decided that what better place to start on my philosophy videos than to talk about logic. These videos might not be quite as interesting as some of the other things I'm going to be doing, but I think they're indispensable when it comes to understanding the basic tenets of philosophy and of, well, any academic pursuit worth its salt, really. What we'll basically be doing today is covering basic logical operations, simple logical formulas. Actually, this is just the series overview. Really, what we're going to be doing is arguments today, but try to keep it under maybe 5 to 6 minutes if I can. In this series, we'll cover simple logical formulas, some fallacies, the nature of arguments. Of course, symbolic logic will be covered at some point, though as I said in my introduction, I'm not particularly well versed in the predicate logic yet, so for now it'll mostly just be the propositional logic. Hopefully that doesn't bother anyone. So, the structure of arguments. An argument consists of premises and a conclusion, and you go from your premises to your conclusion via certain logical operators. For example, suppose you have the premise P and the premise Q. Well, you could conclude from that P and Q by the simple rule of conjunction. And that would be a valid inference, because you know P and you know Q, and you know that they're true, therefore P and Q must follow. You could similarly conclude if you have an argument that has if P then Q, and you have P as one of your premises, then you know, by simple deduction, via modus ponens, that Q must follow from P. In this instance, that's all there really is to an argument. However, there is a little bit more. There is the classifications of arguments, and this can get very important when debating ideas in philosophy and in science and elsewhere. It's a very interesting topic. There's a lot of literature on this stuff, especially on induction. I myself just read a paper by a guy named, I think, Nathan Goodman. I'll have to look that up just to make sure. Let me see here. Called the New Riddle of Induction, and I'll probably be making a video on that soon enough, but for now, we're just going to focus on the basics. So there's different types of arguments. There's deductive arguments of the sort we've been talking about. Things like if P then Q, P therefore Q. Things like that. They are arguments such that if the premises are true, then the conclusion follows from those premises absolutely, as a matter of logic. If you have an argument that is deductive and it is valid, then if your premises turn out to be true, your conclusion will be true as well. Now that's not to say, however, that your conclusion couldn't be true without the premises being true. That, by the way, is a fallacy in many cases. Not all, but it's particularly problematic in conditional statements. A lot of people make the mistake of assuming that, well, if Q is true, P, its antecedent, must also be true. Well, that's not necessarily the case. Take the example of if it rains, then the streets are wet. It's a common example used in logic courses. It could be this case that the streets are wet and it didn't rain, because maybe some kids messed with a fire hydrant. Maybe, there was some sort of accident with a water truck. Who knows? There's a million reasons why it could be the case that the streets are wet, and yet it hasn't rained. That's called the fallacy of affirming the consequent. think. We'll get to that, though. Going from valid arguments, you have a division between sound and unsound arguments. And sound arguments are arguments such that they are both valid, deductive, valid, and their premises really are true. An unsound argument is, well, valid, deductive, and its premises just happen not to be true. Now again, as I said, that doesn't mean the conclusion is false. That is the... Well, that's just basically... Well, we'll go on from there. I lost my train of thought. You'll have to forgive me, these videos are never scripted. I don't intend to script videos. I think that it is a lot better for me, since I'm trying to use this as a platform to learn to teach philosophy, that I go unscripted. So you'll have to forgive some of my stumblings and ramblings, etc. Then we have our invalid arguments, in which, you have an argument whose conclusion does not necessarily follow from the premises. Things like P or Q. P, therefore not Q. That wouldn't follow. That's actually a fallacious argument. There's a technical name for the fallacy, but I'll admit I don't have the exact names of these things down in memory. But that's the sort of arguments we're talking about. But there is another type of argument, however, that is invalid by definition, but isn't necessarily bad. And that is the inductive argument. And an inductive argument is an argument which, while not valid, provides very good reasons, well, maybe provides very good reasons, for believing that its conclusion is true. It doesn't guarantee it as a matter of logic when it happens that the premises are really true, but it does suggest it, or at least attempts to suggest it. Now that's where the problem of induction comes in. You have to define what it means, for example, to say that something is a valid deductive or inductive inference. It's easy to say what's a valid deductive inference. Anything that follows the simple rules of logic is a valid deductive inference, but in induction, we have a whole different problem, because the sorts of arguments that can be made there are vastly different from the kinds made in deductive arguments. Almost all of science involves inductive reasoning. We base we base predictions of the future upon what has happened in the past. We use information gained in experiments to suggest that a thing is true. Now, there is some deduction in science. There has to be. But a lot of it is induction. And so, it's not a matter of logical truth, but it is a matter of likely truth. Even theories are not a guaranteed thing. They're as true as you can prove them. We can't say as a matter of logic that it is the case that gravity really does work via a curvature of space-time. We can say, however, that all of the experimental evidence seen so far confirms that view. So, in the inductive class, we have a distinction between strong arguments, which are the sort that, if all of their premises hold, then they give very good reasons to believe that their conclusions are true. Things like the theory of relativity might be a good example of a strong inductive argument. We see evidence of, say, light being bent around massive objects out in the universe. We see, we take into account, for example, time dilation when we use GPS and certain things like that. Well, those are all very good reasons to believe that it is true that, time dilates around massive objects and at certain high speeds. It's also a good reason to believe that, gravity is the warping of space-time. Now, physicists out there, please do forgive me if I butchered that a little bit. I'm only an amateur when it comes to physics. I have mostly learned my material from high school physics and your occasional documentary on the subject. I haven't taken courses in that, unfortunately. So, but that is a good example of a strong inductive argument. A weak inductive argument, on the other hand, is an argument that has very poor reasons for buying into it. For example, because parrots are able to mimic the human tongue to some extent, and because there are boats, therefore Noah's flood happened. Well, that's a very weak inductive argument. It definitely isn't a valid deductive argument. It's far, 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 far removed from it. But it is a very weak inductive argument. In fact, I would say it's a non sequitur, but of course it's inductive and weak because the evidence doesn't suggest any such thing. It just is unrelated. In general, that is the two classes that arguments fall into. They can be deductive, valid, sound, unsound, or invalid. They can be inductive, and therefore invalid, and strong or weak. In the next bit in this series, we will cover the nature of conditional statements, and perhaps a few other interesting gems. It depends how I decide to break the series up, but definitely the next video will be on the nature of conditional statements. Thank you for watching. I hope that this was somewhat informative. I hope it was a little bit entertaining. I very much doubt it was entertaining. A lot of people find this stuff boring and dry, unfortunately. But I hope it was enjoyed by those of you who did. Till the next time, Duck Lord Demon out.